Here we have a very, very interesting problem. We're talking about radioactive decay. When they talk about the half-life of radioactive potassium, they're talking about it decreasing or decaying. I mean, that's, kind of what happens with radioactive materials. They gradually get less and less and less over time, and that's what half-life is talking about. In fact, I know that you may hear the term half-life off and on, maybe in different science programs on TV or something like that. And what they're talking about when they say half-life is literally the half-life of something is the amount of time that it takes so that you have half of what you started with. That's what it represents. Okay, so here they've said the half-life of radioactive potassium is 1.3 billion years. If 10 grams are present now, how much will be present in 100 years or in 1,000 years? Okay, in the very first sentence here, they gave us enough to come up with our formula. Now, this is following uninhibited growth and decay, so our formula that we're going to be using is the A equals A naught e to the kt. Okay, so in that we have several different variables. We have A, we have A naught, we have K, and we have T. Okay, well, they told us the half-life, which means whatever we start with, let's say it's some x, we're going to end up with 1/2 x at the end, half as much. And the time frame that it takes to make that happen is 1.3 billion years. So now on your calculators especially, be very careful about typing something like that in. If you type in 1.3, then the calculator is going to take it as 1.3 years. So it's best to go ahead and write it all out. And 1.3 billion is 1 and 3 with 8 zeros behind it. So there's 3, 4, 5, 6, 7, 8. Now, the only variable we have left is k, and that's what we're going to solve for first. So using our formula, we'll have 1/2 x equals x e to the k times 1, 3 with 8 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, to get the exponential all by itself, we're going to divide both sides by x, and that will cancel that out. So now we have 1/2 equals e to the, and we might as well put the 1.3 billion in front. So 13 with 1, 2, 3, 4, 5, 6, 7, 8 zeros, and a k. Now we can take the natural log of both sides, which will allow us to bring that exponent down in front. So we have the natural log of 1/2 equals, oh my, 1,300,000,000. 1, 2, 3, 4, 5, 6, 7, 8 zeros. K, natural log E. Now the natural log of E is 1, so we don't have to really worry about that. So our proportionality constant is going to be the natural log of 1/2 divided by 1,300,000,000. 2, 3, 4, 5, 6, 7, 8. There's our proportionality constant. Now we are not done because we have to go through and actually answer the questions that they're asking. So let's do that in the next video so that we don't run out of time.